And the particles also will be rearranged. No? And this compression towards the soil leads to settlement, which can occur either immediately after the construction or gradually over time. Can you turn off your mic? Please turn off instead ng naka-on. So, if there is stress increase in saturated soil, so when you say saturated, sa ganyan ang saturated? Saturated meaning ang ato ang soil is ang voids niya fully occupied with water, no? Saturated soil causes an immediate increase in pore water pressure. So, na ay pore water pressure. Kung increase ang pore water pressure, kung there is an increase also of the stress no, applied or the load applied. So in highly permeable sandy soils, drainage occurs quickly, no, leading to immediate settlement. So unsa may mga highly permeable, so like sandy soils, no. So dali ra kayo ang drainage niya. So this soil particles experiences immediate settlement. Both elastic and consolidation settlement happen simultaneously due to rapid water drainage. So elastic and consolidation. So happens simultaneous na siya. No? But in a compressible clay, due to low permeabilities, ang sa may mitabo, water drains slowly. So as a result, consolidation continues over a longer period of time. So dugay pa ang pag-drain no, kung mga clay nga soil. So then, the consolidation settlement can much larger than the initial elastic settlement. So there are three categories of settlement. We have this immediate settlement, consolidation, or consolidated settlement, or that is primary consolidation. And they have this creep settlement, or we consider this as secondary consolidation. So it's the immediate settlement is the most instant response of the soil to the new stress condition. So again, sandy soil has have this immediate settlement due to drainage. Now, so also consolidate primary consolidation applicable to saturated soil. No? As water is pushed out from the soil pores, the soil particles rearrange and come closer, resulting in further settlement, which is called the consolidation settlement. Are you seeing my slide?
Yes, so
Okay. Creep settlement, or other term is secondary consolidation. This will happen, the secondary consolidation, when some soils continue to reduce their volume for a long time, even after the excess of pore water pressure has been dissipated and consolidated settlement is, and consolidation settlement is complete. So kung mahuman na ang consolidation settlement, na-expel na tanan, nawala na ang water from the soil particles, nya mo continue lang gyapon siya og compress or settle pero gamay na lang gid kay na, but it will take a very long period of time. So gitawag nato nag secondary consolidation. So secondary consolidation starts at the end of the primary consolidation. Kanus nag-ends ang primary consolidation when there is no more water that can be compressed or expelled out of the soil particles. Okay, so there is this immediate settlement equation. So S sub E, or immediate settlement equation, is equals to B times Q times 1 minus the square root of Poisson's ratio, and then multiplied by this influence factor I sub F all over the modulus of elasticity of the soil. So this is the formula for the computation of the immediate settlement. For the primary settlement, or S sub C, or consolidated or primary settlement, SLC, is delta E, or the total change in void ratio caused by the additional load application, over 1 plus E sub O, where it is the void ratio before the application of load, or we say it is an in situ condition of the soil, then multiplied by the thickness of the clay layer. So take note, class, that it is very specific as H sub C, thickness of the clay layer, since we are talking about the primary settlement. So primary settlement usually are encountered when the soil particles or soil types are clayey. No? So it will undergo primary settlement. So The formula also for the total change in void ratio could be C sub C times the logarithm of P sub O plus delta P over P sub O. So uh, this is normal for normally consolidated clay, and that present effective overburden pressure is the maximum pressure that the soil was subject to in the past. No, kanang iyaang P sub O, no, initial. Sumunto ang iyaang effective overburden pressure. Ang effective overburden pressure is the maximum pressure that the soil was subjected to in the past, no, kining P sub O. Of course, ang delta P mo ato ang change, no, from the previous. If the soil is over-consolidated clay and that whose present effective overburden pressure is less than that with the soil experienced in the past. So we use this C sub S log of P sub O plus P, delta P over P sub O. And in this condition, when the sum of the initial, no, maximum overburden pressure in the past, P sub O, plus delta P is less than the P sub C, so we consider the delta E as equals to C sub S, the log of PO plus delta P over PO. So you have to take note of this, and for the total, uh, for over consolidated clay, you have to add this delta E kung ang clay is over consolidated. Take note class, we're talking of all clay. Clay, it's because it is primary settlement. So only clay soil experiences primary primary consolidation or settlement. So kung overly consolidated, kung normal and over, and uh, for the sum, no, of the condition where this critical load, no, maximum critical load applied is having these conditions, no, we consider if it is if PO plus delta P is greater than P sub C, then you have to total. You add all the uh, delta E. Use this formula for over consolidated clay. So nakita na ninyo ang kuan, ang okay. The C sub C is the compression index where it has a formula of 0.009 times liquid limit minus 10, and that for over consolidated ratio, OCR, where OCR is just PC over PO. Okay, so the applied load over the maximum load applied prior to the or in the past. So effective, kini siya effective P sub O, mo siya ang effective load nga gi-apply, no, which is maximum. So then this delta P is the additional, no, additional pressure due to load. So where you can solve also using this equation, no, delta P sub T plus 4 times delta P sub M plus delta P sub B, where this T stands for the top layer, M is the middle layer, and sub B is the bottom layer, no, divided by 6. So that is the delta P computation. For C sub C is the compression index, and take note C sub S is the swell index, where swell index is usually 1/5 of the compression index. No? If there is no given, then it can be assumed as 1/5 of the compression index. And PO is the overburden pressure divided by the effective stress, and delta P is the additional pressure due to load. And P sub C is, muna akong giingon, the pre-consolidation pressure or maximum effective past pressure. Pre-consolidation pressure or the maximum effective past pressure. Okay, so again, We can compute for the compression index. We can compute for the settlement by computing the compression index and swell index. So, having this delta E, no? So, ang importante diri ang delta E nga mabalaan ninyo unsa ang gamiton sa delta E. So, the change in void ratio has this formula. You have the compression index, the swell index with conditions of the clay, no? With particular conditions of the clay. And then please familiarize of the symbol where OCR is the over consolidated ratio. That is simply equals to P sub C over P sub O, where P sub O is the overburden pressure over effective stress. And then your P sub C is the pre-consolidation pressure, which is the maximum effective pass pressure, no? Before the load is applied. And then you have delta P is additional pressure due to the load. So delta P again can be solved using this pressure at the top of the layer, increase in pressure at the top of the layer, and then you have the middle of the layer and at the bottom of the layer. So for secondary settlement, so again, we have this formula S sub S for the secondary settlement, where there is already the secondary compression index, no? And that this is simply delta E over the log of T2 over T1, where T2 is the time after completion of primary settlement and T1 is the time for completion of primary settlement. So time after completion of primary settlement, T2, and time for completion of primary settlement. After, no? After the completion of primary settlement, and then T1 mo ni siya ang pag-end gyud sa primary settlement, di ba? Kung mingon taon sa ganito, ang primary settlement is kung ma-end siya kung wala nay water nga ma-expels from the soil, no? So that is the initial period, or that is also the beginning of the secondary settlement. So again, take note of the formula for the secondary settlement. It is simply the secondary compression index divided by 1 plus E sub P, where E sub P is the void ratio at the end of the primary consolidation. At the end of the primary consolidation. Or simply, it is E sub O minus delta E, no? Times the log of the T2 over T1. So, for an example, application or an example, for the first example of the compressibility of soil or settlement. So if you have the soil profile in this figure and it has a 9-meter layer of sand underlain by 6-meter layer of clay. So kini and then you have there the location of water table is 3 meters from the ground level. 3 meters from the ground level. So you have there the location of water table and the building is to be constructed will cause additional pressure of 50 kPa in the ground. So what is the primary settlement of the layer if the clay is normally consolidated? So using the formula, so we have there for this primary settlement, no? Or S sub C, you have delta E over 1 plus EO times H sub C. So you have there, take note that this layer is mid-height of the clay, no? So up to the mid-height of the clay. So 9 meters layer sa sandy soil. Then ang clay po dayon nga 6 meters below. So muni ang clay. Dayon na siya compression index na 0.36 of void ratio nga 0.95. So ang location sa edge sub C, no, for normally consolidated clay is simply to the mid height of the clay layer. So atong PO is again Itong effective stress, no? 16 times 3, and then 18.5 times 6 plus 19.3. So, diri kay saturated naman siya. So, you have there, uh, for the saturated, you have 19 times 3, and then minus 9.81 of 6 plus 3. So, you can diri pahingon din here. No? So, you'll have 127.71 kPa. So, for the PO, no, to effective stress. So, unsa ang pag-compute sa effective stress? So, you add all these stresses, no? Gamma dry, 16.3, and then for 18.5 for this second layer, and then 19.3, 19 times 3 for the half, no? Half of it, and then 9 point minus ani mo og 9.81 times 6 plus 3, which is here, no? 6 plus 3. Kung diri bottom of ang water table is 3 meters from the ground level. If this is the ground level, so diri ang ato ang water table. So for the PO, then you can solve for the your secondary settlement since we got this value of PO. So you have there C sub C, which is zero point 0.9, compression index is given. C sub C is 0.36 here, log of the PO, which is 107.71 plus delta P. So if there is an additional pressure of 50 kPa on the ground, so you have there 50 over P sub O, which is 127.71, divided by 1 plus E sub O, which is E sub O is given 0.95. So the secondary settlement will then be, so if ang H sub C na to, no, is the clay layer na to is 6 meters, then you'll have there 6,000 mm, no? 6 meters is equivalent to 6,000 mm. So you'll get this settlement in mm. So to be consistent. So you have there your SH sub C, which is now in now 158.94 mm. So that's the requirement if the clay is normally consolidated. No? If the clay is normally consolidated, so this is the formula that you're going to use. So for the second requirement, if there is a PC or pre-consolidation, so you check the condition PO plus delta P is equals to 177.71, no? So you have there 127, which is the PO we solved a while ago, plus delta P nga 50. So it is 177.71, which is less than the pre-consolidation pressure. So ang pre-consolidation pressure sa lab pa na, no, natay pressure nga i-apply sa soil para makita na to sa iyang settlement, no, pre-consolidation. So you have there less than 190. So therefore, we use this settlement formula for the condition, no, of delta E, which is equals to C sub S log. So makita na nato dito kini nga condition dito sa previous nato nga slide nga will indicate what delta E formula should we use, no? So C sub S log of PO plus delta P over P sub O. Therefore, if you input all the given values, so you can solve C sub S is not given, so we assume that it's just 1/5 of the C sub C. Then log of PO, which is we determined a while ago, 127.71 plus 50 over 127.71. Then divided by 1 plus E sub O multiplied by the height of the clay layer, which is 6,000. So again, why is it that 6,000 lang ang height? Gani, ang H sub C? Okay? We're talking of settlement. So kung mayroon kag settlement, ito gid siya sa clay layer. Okay. So therefore, and then the third is if another pre-consolidation is given, so you will have to check again if the pre-consolidation pressure is lesser than or greater, again, greater ang PO plus delta P sa ato ang P sub C. So, unsa pud ang formula gamiton? So, ang may tabo, no? We will use this delta E formula for the determination in the uh, primary settlement, no, formula. So, already gihapon, no, we add na to 170 over 107 plus 0.36 log of, okay, this value, and then 1 plus E sub O, which is 1 point, and then 6,000. So we'll have now the secondary settlement. So in the previous, no, so we consider this in letter A, pila yang settlement lang. 158.94, and letter B is 31.79 mm. And then if there is a pre-consolidation, no? So therefore, for normally consolidation, naku kayo siya, no? Kung normally consolidated lang siya. Pero na pre-consolidation pressure, meaning ato daw i-consolidate una, no? Natin introduce nga pressure, no? Sa soil. So kung introduce na to og pressure ang soil daan, tapos ay pag ito mag-add og load, niya. Ang condition kung gi-pre-consolidate na to daan ang soil, no? Ay ata nag-add og another load, so it will differ then, no? So if it is greater than the pre-consolidation, so the sum of the effective plus the uh, additional load is greater than the pre-consolidation pressure, so mo lagi ni ang ato ang formula sa delta E. So by that, you will determine that uh, settlement is greater, no, kung dako pod ang ang pre-consolidation pressure nga i-introduce. Kay kung kung 190 ang iyang secondary settlement is 31.79. Pero kung ipagamya nato ang iyaang pre-consolidation, no, mas taas siya og settlement, no, primary settlement, mas taas siya og primary settlement. So this is the condition, no? So for normally consolidated, so walay pre-consolidation nga gihimo, normal lang gid siya kung unsa na, then ang settlement, no, in this condition is for this type of soil is dako kayo 158.94, whereas kung i-pre-consolidate na to daan, butangan na to daan og pressure, so it is lesser. So kung dako ang ato ang pressure yatag, pag pre-consolidate daan nato, so compress na siya, no, kamay na lang yung settlement. Pero gamay-gamay, so settle pa gid siya further. Okay, so another is there is a 2-meter clay layer that has a void ratio of 0.92, specific gravity of 2.72, and a liquid limit of 40%. Above the clay is a 3-meter thick layer of sand with a void ratio of 0.5 and 2.62. So the water table is located 1.6 meters above or below the ground surface, and a 3-meter thick backfill is placed on the ground surface with a unit weight of 17.3 kilonewton per cubic meter. Plus for a while ha, kaya nanawag ako sa tubagon, kadjat lang. Yes, sir. Yes, sir. Uh, yes, sir. 10 o'clock, sir, ba? Yes. Yes, sir. Inform ako ang other persons. Sige. Sige. Ako rin PM, sir. Yes. Hello, class. Napa mo diha? Okay ra mo? Nagtubag sa ako kadyot sa nahinanawag. Hello? Tubag. Tubag. Tubagad ako ninyo. Napa ba mo diha?
Yes, Doc.
Yes,
Okay.
ma'am.
Continue ta, no? Another example. Papakay na to may meeting unya na sani na mag PM sa ko sa katong sani mga chairperson. Ginoo ko 2026. Asa naman to? 2025. So tanawan ninyo na ang problem. Ito naman itong mga chair. Dunay 2 meter clay layer niya na siya void ratio given GS and LL. And then, ang clay layer, above the clay is a 3 meter thick layer of sand. No? And with a void ratio of 0.5 and GS of 2. Ano to? Okay. 2.62. No? And then the water table is located 1.6 meters. So muna siya below the ground surface. And a 3 meter thick backfill is placed on the ground surface with a unit weight of 17.3 kilonewton per cubic meter. So, sa pasabot aning backfill, no? Okay. For our layers, so you have there in the given figure. And then what is required is you compute for the compression index. So kung na kay compression index nga formula is 0.009 liquid limit minus 10, you can get the compression index of the clay layer. No? Compression index of the clay layer, which is 0.27. So ang clay is na siya liquid limit nga 40 given. No? So a 2 meter clay has a this one 2 meter clay has liquid limit of uh, 40%. So you have there the C-subsmith. And the second requirement is effective pressure at the midpoint of the clay. So saan pagkuha sa effective pressure at the midpoint of the clay? So take note that there is a 3 meter thick backfill on the ground surface. So what will happen in the computation of effective pressure at the midpoint of the clay? So therefore, imo ning i-appeal, no? Ining ang 17.3 kilonewton per cubic meter na uh, backfill, no? Nya ang katason niya kay 3 meters. So if you multiply that, you will get a pressure of uh, 51.9. So manang surcharge na to no backfill mo siyang equivalent sa surcharge. Okay. So, let us compute the effective pressure, no? So sa sand, kay wala may unit weight given sa sand, no? If kung naay void ratio, unya given po dayon ang specific gravity, then makakuha taog, makakompute ra taog unit weight sa soil. So for the dry condition of the unit weight of the sand based on the given specific gravity and the void ratio, then we say that the dry unit weight of sand is 17.13. And for the saturated, of course, we have this formula again. Then you can compute. For the clay layer, na po yung nanawag class, kadjot ng class. Wala pa na set, sir. Kamulo pa. Yes, sir. Yes, sir. Oh, mingaw kayo. Nagklasiko. Okay. Sorry, class. Kaya sa amin good nga busy kaya ang mga kuan. Sana ta. So sa clay layer, so makakompute yapon ta og saturated unit weight sa soil, no? Using the formula. Di gyud ninyo nilimtan. So let's start with the calculation of the effective stress at midpoint of the clay. So PO then will be equals to 17.13. So nanatanong sa dry sand. At what point 6, meaning it's above the layer of the water. So, water table pala. So, mahitabo. Ni mo? Imo ang test paper. Tagit lang klasa kay na ay nagkuha o test result sa exam ay sir, sorry yan. Okay, so try to continue looking the solution na naman na inyo ating kuan. Naman na inyo ang copy. Sarap sir, no? Oo. Na may copy ninyo. Duha? Wow.
Ay, marupon na siya mo.
Mura?
Sarap.
Wala lang, sir.
Thank you.
Sige, sir. Okay. So, pag-calculate sa effective stress, you have there 17.13. That is at the sand layer. So, during a portion, no? Natay dry unit weight sa sand from 1.6. Then, you have there 20.40, that is the saturated, this second unit weight, which has a depth of 1.4 meters. And then 18.6, where this is the gamma sat of the clay. Since the clay layer is 2 meters, at the mid of that is just 1 meter, no? And then minus 9.81, ang water is 1.4 plus 1, di ba? Gikan diri. So, sa unit weight sa water. However, sa clay, so kanira na, diri nga portion. Pero, it should be deducted, no, kay effective man. Effective stress. So, therefore, our P sub O is just simply 51.02 kPa. So, can you follow? Plus, so you have now the effective pressure. Now, ang second last or the last question is compute the primary settlement for normally consolidated clay. So assume that it is a normally consolidated clay. So you have this formula for the secondary or the primary settlement or uh, the primary consolidation. So you have there the compression index and do not forget this formula class. Okay, so by simply substituting compression index is given, which is we solved 0.27, and then P sub O, we already determined this, and delta P, which is equals to 51.9, no? Here, the surcharge, 51.9 delta P over 51.02, the one that we solved a while ago as the P sub O, or effective stress at the mid of, or effective pressure at the midst of the clay layer. So therefore, ang kini nga condition ang primary settlement niya, no, kung naay additional load din nga 51.9, so mahimo ni siyang 85.71 mm. Okay? So, we still have lots of formula problems here, no? You have to go over this as part of your sit work. No, you copy and then you solve. No, you try to look at these problems. Muna ning katong sa formula nato, no, kung uh, ang condition, no, you have there the pre-consolidation applying 2:1 method. So you have there the layer. So elastic settlement. May balik ka. Okay, let murag. Kini nga problem is uh, so let's take a look at problem number 3. So, ang problem number 3 is compute the elastic settlement of the footing if the Poisson's ratio is 0.32 and the modulus of elasticity of the soil is 16,000 kPa and the influence factor is 0.88. So therefore, this is for the elastic settlement, diba, or the secondary consolidation. So you have this formula B sub BQ 1 minus the square root of the Poisson's ratio times the influence factor over the modulus of elasticity of the soil. So therefore, solving our Q, no, or net pressure at the base of the foundation. If the foundation is as a dimension of 3 by 3 meters, then the load transmitted from the column towards our foundation is 710 kilonewton. Then we'll have, or the net pressure at the base of the foundation is 17.889 kPa. So we'll have this immediate settlement or the elastic settlement, no? Immediate settlement or the elastic settlement of 11.68. And then for the primary consolidation settlement of the clay, so you have there the formula. So you have there delta E over 1 plus EO times the thickness of the clay layer. And then you have to determine this effective stress, no, at the until the mid uh, portion of the clay layer. So therefore, ang ato ang delta P ani, no, will be this the top and then the middle and the bottom layer factor or considerations. So for delta P, you have there 710 over 3 plus 6. No? 3 plus 6. So you have there uh, squared, so P over A. So you'll have there 8.77 kPa. And then at the middle of the layer, so on some put 710 divided by 3 plus 8. No? Squared, then you'll have there. And then at the bottom, you have 3 plus 10. No? Okay, so you have there your pressure at the bottom, which is 4.20 kPa. So applying or the 2 is to 1 method, then you can get this delta P as equals to 6.08 kPa. So naanatay delta P and solving for the uh, consolidation settlement, then you'll get an answer of 16.91. Take note this H sub C, it is the clay layer. So kung saan thickness sa clay layer, muna siyang H sub C. So yun natin PO nga 119.96 nga we solved a while ago. And then of course ang ato ang delta P atong gisolve nato from top, mid and bottom layer nga pressure using 2 is to 1 method, no? Divided by 119.96 kPa. And of course, quantity, you divide it by 1 plus E sub O, and the product will be multiplied by the clay layer, which is 4,000 mm or 4 meters. So you'll have a secondary settlement of, or consolidation settlement of 16.91. Compute the primary consolidation. Yeah. This is the primary consolidation, S sub C. S sub E, matong immediate, no, or elastic settlement. So, ika-third is, ani, total consolidation settlement of the clay 5 years after the completion of primary settlement. So, time for the completion of primary settlement is 2 years. And secondary compression index is 0.02. So, as you can see in the formula, it involves time, no? T2 over T1. So T1 mo to siyang pag-end sa imong primary consolidation settlement. Then T2 mo ni siya ang uh, end, no, sa imong secondary settlement po. Uh, time or time after the completion of the primary settlement. So for the total settlement, of course, you'll have the immediate, the secondary settlement, and uh, the primary and the secondary settlement, di ba? Primary consolidation and the secondary consolidation. Primary, immediate S of E, S of C is the primary consolidation, and S of S is the secondary consolidation. So, muna ang total settlement. So, mag-solve tag, immediate, mag-solve na po tao, secondary. So, therefore, solving for your delta E for the uh, S of S, so you can solve here the settlement. Saan ni? Oh my God. So you will have your settlement, total settlement of 48.57. So we solved this already, the immediate settlement and primary consolidation in the previous problem. Diba? Okay. So you can go over no, on this problem. Do you have questions with problem number 3 and how to solve this and how this problem is solved? My clarification. I think we will just end there, no? And then you can go over with the rest of the sample problems. We have about 8 sample problems. Okay, please ask me if you have some clarifications with all these problems, sample problems. And please take note to study. You'll have our face-to-face already on Tuesday. I will find a classroom for that day for our face-to-face long quiz for the two topics that we have, the bearing capacity and this lecture 8, so lecture 7 and 8 topics. So go over all the sample problems, study, solve again. Okay? So we have lots of sample problem there. So now time rate consolidation, no? With very specific formulas that you need to uh, take a look, no? Balik-balik lang man siya, formula-based rigid kayo siya. And then you analyze. So you can go over all these lengthy sample problems. And please study this for our long quiz on Tuesday. Ay, Tuesday. On leave pala na ako. Next week, Friday na gina ito magkita face to face sa 31. So pagka 28 ay na may problem set akong ihatag no for all these problems. So online ra ko o hatag ang activities sa 28 kay on leave ko. So 31 na ta nagkita no for our first final quiz. So Johanna, ka-topic lecture 7 and lecture 8 for our quiz on Friday. Do you have questions, class? We'll end there. May pangutana?
O wala ko din sa table na. So, may highly at diretso.
Yes, abapon. Unsay pangutana?
Excuse me, ma'am. Ang karong 31, ma'am, kay holiday siya, ma'am.
Holiday na sad no?